In 2018, NASA's radar pierced the southern ice of Mars and detected something scientists weren't ready to face: a vast reservoir of liquid water buried beneath frozen layers where life could be hiding right now. The official reports called it an enigmatic signal. But behind closed doors, researchers debated if this was the strongest evidence yet of an alien ecosystem, shielded from the deadly Martian surface. This is NASA just discovered something terrifying on Mars. And it sets up a high-stakes question. If the red planet was once blue and teeming with rivers, what did it leave frozen beneath the ice? The answer could upend everything we thought we knew about our neighboring world. Mars today is a frozen desert, but its surface tells a story written in stone. Carved into the planet's crust are sprawling river valleys, twisting for hundreds of miles across barren plains. These aren't random scars. Orbital images reveal clear evidence of ancient channels, branching like veins, and broad delta fans where rivers once emptied into lakes or seas. Along crater rims and low-lying basins, faint shorelines trace the outlines of vanished megalakes. Even from orbit, the patterns are unmistakable. Mars was once shaped by running water. Minerals collected by NASA's rovers add another layer to the puzzle. Kaolinite and spinel found in Jezero crater only form in environments with abundant liquid water and warmth, conditions that could have supported life. Perseverance's latest campaign uncovered volcanic rocks altered by water, a surprise in a region thought to be mostly sediment. These rocks hold chemical fingerprints of ancient rain and rivers, preserved for billions of years. Roger Wiens, a lead scientist on Perseverance, puts it plainly: these minerals form where there is intense rainfall and a warm climate, ideal conditions for life as we know it. For decades, scientists debated whether Mars was ever truly habitable. The surface evidence now leaves little doubt. Mars was once blue, alive with water, and possibly much more. Deep beneath Mars's southern ice cap, something unexpected is bouncing radar waves back to Earth. In 2018, the European Space Agency's Mars Express orbiter picked up a bright, unmistakable echo from 1.5 kilometers below the surface. The MARSIS instrument, designed to probe for buried secrets, registered a reflection so strong it rivaled signals from lakes hidden under Antarctica's ice. Roberto Orosei, leading the Italian radar team, spent months under scientific siege, fending off doubts, double-checking every possibility. His group argued the data pointed to liquid water, a briny lake trapped far below, shielded from the planet's deadly radiation and subarctic cold. But there's a catch. At these depths, temperatures plunge to around 205 Kelvin, minus 68 degrees Celsius. Pure water would freeze solid. Only a cocktail of salts, far more concentrated than any found on Earth, could keep it liquid. Some researchers argue the radar could be fooled by layers of clay or unusual frozen sediments. Others say the echoes are too bright, too consistent, to be anything but water. Orosei's findings, published in Science, ignited a firestorm. If these lakes exist, they could be refuges for life, habitats untouched for millions of years. The debate rages on. Are these signals proof of hidden lakes or just a trick of Martian geology? One thing is certain: whatever lies beneath the polar ice, it's sealed off from the surface, protected and possibly alive. If Mars still harbours secrets, this is where they wait. In 2018, the Curiosity rover drilled into ancient mudstone at Gale Crater and found something that sent scientists scrambling: complex organic molecules locked inside rocks more than 3 billion years old. The sample analysis at MARS, or SAM, instrument heated powdered samples to hundreds of degrees, then sniffed the gases released. The resulting mass spectrometer traces revealed thiophenes, sulfur-rich carbon compounds, and aromatic rings, the kind that form from long, slow chemical reactions in watery environments. On Earth, these molecules often come from living things, but they can also form without life under the right conditions. The excitement was immediate. NASA's Jet Propulsion Laboratory went into overdrive, rechecking every calibration, every control to rule out contamination from the rover itself. The signals held up. Perseverance, landing years later in Jezero Crater, targeted the ancient river delta and found even more carbon-bearing clays, the same minerals that on Earth are famous for trapping and preserving traces of life. Inside thinly layered rocks, Perseverance's cameras captured laminations that look strikingly similar to microbialites, stone structures built by microbial colonies in shallow lakes back home. While not proof of life, these findings show Mars had the right chemistry and the right environments for biology to take root. The building blocks are all there, sealed in stone and clay, waiting for the next breakthrough. Methane on Mars is a riddle that refuses to be solved. In June 2019, Curiosity's SAM-TLS instrument registered a sudden surge, 21 parts per billion by volume, right inside Gale Crater. That's nearly 60 times the usual background. Yet when the European Trace Gas Orbiter scanned the same region from above, its sensors found nothing, not a whiff. The TGO's upper limit, less than 0.05 parts per billion, flatlining across the Martian sky. Two state-of-the-art instruments staring at the same planet, coming up with answers that couldn't be more different. NASA's public statements grew careful. Internal emails later surfaced show managers debating whether to release the methane numbers immediately or wait for more checks. One 2018 memo warned, "We must avoid triggering an unsubstantiated media firestorm." The reports slowed to a trickle. Meanwhile, planetary scientists outside the agency pressed for answers. Michio Kaku, usually the skeptic, called the methane spikes the most exciting hint yet on Fox News. Neil deGrasse Tyson asked if we were looking at Martian geology. Something or something alive and breathing just beneath the surface. Mars's methane, earthquakes or microbe farts, either way, it's wild. The silence only fueled speculation. If methane rises and falls with the seasons, and if biology is even a remote possibility, what is NASA not saying? The next clues would come not from chemistry, but from the rocks themselves. Curiosity's Mastcam snapped a set of images on Sol 1545 that set the internet ablaze. Thin, branching tubes jutting from Martian bedrock, clustered like fossilized worms. To some, these shapes looked eerily familiar, almost like the microbial mats or tube fossils seen in Earth's oldest rocks. Enter Barry DiGregorio, a British astrobiologist, who argues these features deserve more than a passing glance. He points to their symmetry, their clustered arrangement, and their context in ancient lakebed sediments. But NASA's geologists see something else entirely. According to official analyses, these tubes are the product of mineral-rich water seeping through cracks eons ago. As the water evaporated, it left behind veins of hard minerals, later exposed by relentless Martian winds. What looks like a fossil is, in their view, the aftermath of chemistry and erosion, not biology. The debate rages on social media and in peer-reviewed journals. Are these just rocks, or are scientists too quick to dismiss the possibility of ancient Martian life hiding in plain sight? On May 4th, 2022, NASA's InSight lander recorded a seismic event that rattled the Martian surface for 6 straight hours. This was no minor tremor. Its magnitude hit 5.0, the strongest Marsquake ever measured. Scientists scoured satellite images for a fresh impact crater, but found nothing. The energy had come from deep within, not from above. Bruce Bannert, InSight's principal investigator, summed it up. Mars is still shaking. The planet's crust flexes and groans, hinting at hidden forces far below the dust. While Mars proves it isn't geologically dead, the countdown to human arrival is underway. NASA's Artemis program is laying groundwork for the first crewed Mars missions, targeting the late 2030s. SpaceX's Starship plans keep shifting as engineers debate how to land without contaminating possible Martian ecosystems. Lisa Pratt, NASA's Planetary Protection Officer, warns that a single microbe from Earth could rewrite the story of life on Mars. Every new quake, every sign of activity sharpens the dilemma. Are we explorers, or are we about to disrupt something alive and ancient? The race to Mars is no longer just about technology, it's about what or who we might find waiting. NASA's own data confirms that Mars once held rivers, lakes, and possibly even oceans. In 2018, radar from the Mars Express orbiter revealed strong evidence for subsurface liquid water beneath the South Pole, raising new questions about what could survive in those hidden lakes. Rovers have detected complex organic molecules and seasonal methane spikes, yet the origin of these signals remains unresolved. Images showing tube-like features continue to fuel debate, with peer-reviewed studies leaning toward geological explanations. Meanwhile, seismic readings from InSight in 2022 proved Mars is still an active planet. Today, as NASA's Artemis program and private missions move closer to sending humans, planetary protection protocols are under review. Despite decades of exploration and more than 50 missions, whether life ever existed or still persists, life on Mars remains unproven. What is clear, the evidence for a once habitable world is stronger than ever, and the search for life on Mars is far from over.